Good morning everyone. Greetings from Cologne to Silchar. Thank you for joining this presentation here in the showroom for electrical power training systems. But first let me introduce myself. I'm Jörg Littwig. I'm product manager for the electrical power engineering and as well the automation technology at Lucas-Nülle. I'm also responsible for the development of the electrical power engineering training system. Today I would like to give you a general overview over the electrical power engineering system of Lucas-Nülle by using the new interactive multimedia courses. So most of the topics I make some experiments with the equipment you see behind me. For example, generation with a synchronous generator, transmission lines, distribution with double bus bars, as well as consumption. First, I'd like to show you the power generation. We have here a synchronous generator, here the servo test machine system which drives this generator. We have here the exciter voltage control, and now I'd like to show you how it works with the manual synchronization. First, I start the engine which speeds up the generator. Then I switch on the exciter voltage, and you see now here the synchronization unit where you can see the voltages of the generator and the mains, as well the frequency, as well the difference between the voltages of generator and mains, and the synchronous scope for better seeing how the angle is. So now I have to synchronize by changing the speed, and I have to control the voltage of the generator by changing the exciter voltage. If it's synchron, I can switch together. Now it's synchronized, and now I'm in a torque control so that I can generate the power into the grid. Now there is the power, and if I want to produce inductive power, so I can vary the exciter voltage or generating more power. This is the real power going into the grid. So now we will make the automatic synchronization with this multifunction relay, I start this application. Now this function relay starts the exciter voltage, starts the generator, and is speeding up now. You see here synchronous scope is also working. The voltages are the same, and now it's already synchronized and it's on the grid. And here you see that it automatically generates the power which is needed, and as well the control of the reactive power is also made by this multi-function relay. As well as protection of the generator, many functions like over voltage, under voltage, frequency control, over current are integrated in this device so that this works totally automatically and protected as well. So now I can stop the device, and the power goes down, and after the power is going down, it would be switched off and everything is going down. Here you see the part of distribution and also transmission. Here you have the double bus bars with the outgoing and incoming feeder, as well as one double bus bar with the coupling element. You can control these bus bars by using the switches here, as well by the software. For example, I can switch off here the whole power or switch on the whole power. You can change between the two bus bars by using this power switches and the feeder. Everything can be controlled by this way. If you make an error, you hear some noise, so that this what you like to switch is wrong. The transmission line I will show you on another experiment instead. Okay, here we see the transmission lines as transmission line and also as cable, underground cable, as well the transformer stations. And here you can look what is going on if the power of one system goes higher. You see the difference between in and output of a transmission line. As well, you can change the length of one transmission line by changing this mask. Now we have 300 kilometers, and now I change it back to 150 kilometers. Very easy setup for changing. You can make some earth fault compensations with a Peterson coil, and you have here the combination of transmission lines going over a transformer station to a cable transmission, and then here at the end we have also the protection technology. Here an example with a time over current relay with directional feature. I can show you here now the work of this relay. I start the relay. We have here a tester, and we can now start the relay and stopping the time for the tripping of the relay. Here we see the time, nearly 5 seconds needs the relay to trip this current. Here we have the experiment for the power consumption. We have the static loads like resistive loads, which we can change here, the capacitive load, as well as here some inductive loads. And here are the dynamic loads in case of a asynchronous generator, which is connected to this machine test system, which can generate a moment to this asynchronous generator. Now I'm starting here the generator, and we have here the reactive power controller, which is switching the capacitive to making the Lucas-Nülle speed up to 95. So now I can generate here a moment and looking what is going on here on the power of this instrument. Now this is switching off these in the reactive power controller. Here you see the SCADA software, which can control and observe all the devices you have in your power lab, as well as the double bus bars and the power quality meters, the time over current or the protection relay generally, also the machine test system or the wind power plant. So here you see the data. If I'm variating, for example, the load, you see directly the variation of the load, even if it's from another experiment. Also, you can, for example, switch on some power switches by using some buttons here. You can program your own logic for your power lab, for example, that if the power is too high from one producer, you can switch him off, or you can add some new power plants by controlling this SCADA software. And you can observe everything by the SCADA logger. So here you see what is going on with your loads, with your generator. You see if one protection device is tripping. All these you can see and observe with the SCADA software. As well as compatible to the grid, to the net. There's existing one net version, so you can make a remote control from every PC in your lab. So thank you much for your attention, and goodbye from Cologne.